bit of time that we have, I want to highlight how to get at that data, how to download it, maybe how to answer some of those same questions like what Brian did in terms of what was submitted with this. So the first place that I want to highlight is the globe visualization page. And if you haven't used that before, you know, it's just on, if you go to viz.globe.gov, you end up at a location like this. And when you click down, the protocol layer here is where you can find the biosphere. And then for us, we are looking at, where was it? Brian? This is live.
Which are you looking for?
The tree height. I thought that was under the biosphere.
No, tree height's only an ADAT.
Ah, see, this is why we can't do that here. So
we've been fighting to get it on the Viz, and what I should mention that once we, you know, Globe has said that once they the tree height tool comes out for the app, they're going to include that on the Viz. So
yes, so that right there is a limitation, right? Like, how do you actually get at and see this data? And so where you actually go, I'm going to just do a quick search for you and show you, is there is this website that will allow you to go in and download the actual data itself. And so as a scientist, this is one of the first things that I go and do is find out where is data. So inside of here, you can choose your protocol. And so this is where you can get it to all of the data inside of Globe that's out there, including things like snowpack. And so you can scroll down and you actually see here is the biometry tree heights. So that's what you need to just go in and add. And when we apply that filter, we can actually see across the time, we've had about 1,000 sites actually put in data. And so you can actually obtain the measurement data, the tree height, for the entire time of the globe time period. So that will be interesting, but that's a lot of data, right? And so for ours, what we actually want to do is just go in here and we can limit our data time period down to just this last little bit here, and going from our January 1st to our January 31st. And then just click apply. And now you notice we only have 13 sites that contributed measurements. So you can download the summary data and you'll have a table that you can work with there that just gives you some quick information, or you can obtain the measurement data. And so when you download the measurement data, you notice all of a sudden we have, from 13 sites, 660 measurements that were made. So I want to say congratulations and thank you guys for all that hard work, because that shows the dedication of a small group of people and the power that they can actually create. So you can download that and you end up with the spreadsheet. So at that point, you know, I'm hoping that some of the Globe teachers can lead you into how to take that spreadsheet and do something with it, or how to get it into some software. Because once you have that data, you can then import it or open it up into Excel, or in this case, I have a Google Sheet that is there. And so I've actually, I have a link to this table inside of here so that you can actually go and explore that on your own. But you can see inside of here are a variety of field names that describe who made the measurement with the organization name, the site name that's there, the latitude and longitude that you recorded for that site location, the elevation of it, and when you actually made that measurement. And then we have the tree height locations as well. And then importantly, what we have here is the elevation of the tree. And then all the way over here in column L, we finally have that tree height that you measured. And what I wanted to point out is that, you know, notice we have one measurement here, a pine tree, that is 22 meters tall. And then we have another one, another tree that is 17.8333 meters tall. And so when I was talking about that precision and accuracy of our measurements, it is this 17.8333 that is what I'm talking about in terms of our decimal points. But so you can see that we actually have all of these measurements that you entered into the database. And so we can go in and you can find your individual measurement on the day that you made it. Or one of the questions that I have that I will take a little bit of a moment and let you guys answer is, what do you think the smallest tree measured was? So you can just type in some answers into what do you think was the shortest tree measured?
Go ahead and type your answer, what you think it is, into the chat.
Yeah.
Not everybody at once, please.
So one of my questions, for me as a scientist, is seeing that there's 660 measurements or 670 measurements that were made during a 1 month period. What I just kind of, before I even look at it, what's the shortest and what's the tallest? All right, so we have 3 feet, 5.9, what? Are there units with that, Brian, that you can include? I like that. So 5.667 meters. Nice. 1.3 meters. Yeah. So Brian, right about 10 minutes ago, if you were paying attention, gave you the answer for what we would expect to be the shortest tree that was measured, right? Which should be 5.0 meters, right? That should be the shortest tree height measurement that we see in here based off of that criteria, right? And so one of the things that we can actually do is put in a nice little formula into our spreadsheet that actually allows us to say, I want to calculate, say, the minimum value, and I know that it's all in this L column, right? So I can just go in and basically show me the minimum for this whole entire value field. So I hope for some people this is a little some computer science review, but if not, I'm hoping that you'll find some interest in this. So using that formula, we were able to find that the minimum, the shortest tree that was reported was 5.1 meters. And so I did the same formula and asked for the maximum value out of that whole list. And we came out with the tallest tree that was reported was 31 meters tall. So when we're talking globally, that's a pretty good sized tree. And so what I find interesting is when I am looking at a data set is to look at this minimum value and the maximum value that's there to understand the spread of tree heights that were measured by you all. And so you can go through and do just some of those what we call descriptive statistics, including what is the average tree height. And so I calculated that as well and came out with our average tree height was 17 meters tall, which I think is just interesting to know, that's sort of the tree height around you all. And then one of the things that you can do with a spreadsheet is actually create a graph or what's known as a histogram that actually will for every one of those measurements, put it into a 1 meter category. And so I can, this gives me the number of counts of tree heights. So we have a little over, about 15 tree heights trees that were measured that were between 5 and 6 meters tall. And you can see this distribution of values of tree heights that you guys measured. And so this right here is a really good range of values, as well as we're getting some really tall trees and we're getting some really short trees. So just right there is a really interesting way to start exploring the data set that was created during this 1 month period by this group. And so that right there is something that you could actually take and write up and look at your contributions to these tree heights and write that up for the Student Virtual Science Symposium or the Regional Science Symposiums that are out there. Because it's basically looking at what is your tree heights in relation to this larger sample that has been done out there by our group. So, you know, I think that range is really good. I'm excited that we're getting some taller trees that are out there. And so I think, you know, I find one of the guiding questions that I have really is this question of where is the shortest tree in my community and where's the tallest tree in my community? And then, you know, in April, are we going to end up with kind of that same distribution, or are we going to end up with a different shortest tree or a different tallest tree? That's something I'm looking forward to seeing if you guys can help answer that. So I will just kind of ask if there's any questions that are out there. I do see one over in the chat. Let me move that over. So yeah, so some of the trees that we have out here in Oregon, I didn't put it into the Globe database, but some of the trees that I've measured over the last 15 years of doing forest tree height measurements are actually almost 90 meters tall. And so almost 3 times the tallest tree that was measured by our group right now. And so I'm really looking forward to being able to use the new tree height measuring app and seeing how many of the tall trees around me I can actually add and contribute to getting maybe one of the tallest trees out there. So I want to encourage you to maybe take this on as a challenge of finding in your community what the shortest tree is and maybe the tallest tree. Because those are really interesting pieces of information that can lead to different questions, deeper questions, and really lead to what Brian was asking at the beginning. Why do you have those trees that are growing that location? And why do you have some trees that are growing 30 meters tall? So I will turn it back over to Brian, and I have a couple other websites and things to share, but I will let Brian do a little talking and sharing with you.
All right. Thank you, Peter. Let me hop back in here and share my screen. And I'm going to show you just 2 things. Peter showed you the GloViz and the ADAT specifically. So I'm going to pop over to another part of the site. I'm going to actually go to the Viz. I got to pop back out of there now. Let me pop here. All right. All right, so I'm going to go to the Globe data, go to the visualize data, enter the Viz system. I want to show you here that the data you collect, what you can do is you can add on a data layer, which is basically a satellite layer. And let's do it, for instance, I'm going to go up here to, and everybody should be seeing this, correct? Yeah, all right. All right, so we have, let's do land cover. Okay, we'll go to land cover. We'll just do, let's just pop photos on there for now. And then what we can do is we'll hit submit, and You see, that gives us the 1 year. We'll do just the one. We'll do the 1 day and do an update. The 1 year covers a lot of the map. So yeah. So let's then go. If you can see here, and it's not labeled very well. If you look up here over to the right of the data layer of the protocol layers, you have these 3 dots, and if you click on that, that's where you can choose a base layer. And what that means is if you click on that, you click on these, open street, satellite, hybrid, but you can also have NASA satellite data options, everything from corrected reflectance to Earth at night to aerosols. But let's just, for instance, let's just do land surface temperature just so you can see what this looks like. So if I click on that, what happens here is that the map is then populated with the actual satellite data. This is from Terra. And you can go back to any date. Let's just go back, let's say, to February 1st. And then it'll give you that, and you can go back and, look at that data over time. You can do that for lots of things. You can do that for looking at chlorophyll if you're looking at the oceans or, the bodies of water, precipitation estimates, and SMAP as well. So you can do all these different measurements. But what's cool is you can look at your data, click on your data, and then compare. Let's say you were looking at, you were doing surface temperature, and then you can click on your site for surface temperature measurements and then see how close you were by looking at your data versus, an estimate with the satellite data. So it's very cool to do. It's pretty easy. We wish we had more up there, and we're trying to get more of the satellites and instruments up there. Hopefully, we might get ISAT-2 tree height data up there at some point. Keeping my fingers crossed, but that's a discussion in process. So that's just another way that you can, look at your data. You can compare it to the satellite data, even though we don't have it all here. But I'm going to show you another site here that allows you to do even more, but it's not on Globe. It's called NASA WorldView. And you can see the URL. Let me go back to the regular page here. It's just worldview.earthdata.nasa.gov. And what you see here is you're seeing a global map, and you're seeing Terra Modis imagery in the background. But what you can do is you can look at basically any type of data set that you would like. Not tree height yet, hopefully once ISAT-2 is released, but we're going to just show you an example here. And this, you can do different things. So as you see here, there's a little button that says Add Layers. I'm going to click on that, and I'm going to click All. And you can see here all the different data layers that you can look at. And what that means is when you choose one, it'll be then put onto the map that's behind this. So let's just look at snow cover for one. We have it from Aqua Modis and Terra Modis. So let's do both of them. We'll do Aqua, so you just click here, and then we'll do Terra, click here, and then we'll click on the map to get rid of it or just X that out. As you can see, some data showed up, but what I'm going to do is to make it easier, I'm going to get rid of the clouds, the cloud from Terra Modis, corrected reflectance. So down here, there's a little eye. If I click over that, it'll take it away. But now what you can do is you can go and see all that snow cover data. And if you scroll over the colors, let's zoom in a little bit more here. So if you scroll over the covers here, over the colors, you can see wherever you are, it's changing on the color bar to the left, okay? This one happens to be the snow cover from Terra Modis, okay? And then if we happen to just close this one out, this here is the data from Aqua Modis. It's looking at this snow cover from basically, there's two different, satellites with different instrument, but what you can do is you can look in your area and do this, and you can go on and explore this. I haven't explored the whole thing yet because there's so many different data sets available. But let me show you something cool, and this is something I showed with the SMAP earlier, so I'm going to just show it with this one, though. If I want to create a little movie of some data that I collected, of the dates, let's say I collected, let's say I want to look at the snow cover data for the globe from these satellites over a certain period of time. So you can click this little movie icon down here, little movie camera, click that, you get this little dialog box that pops up. So let's go to 2018, let's say, I won't make it too long, let's say September 12th, that's fine. and then through today. And then what we can do is we can determine how fast we want it to show, down from, you know, 0.5 frames per second all the way up to 9.5 or 10. That's pretty fast. So let's go kind of in the middle here. And if you click on this, what's going to happen is it's going to create a quick little movie for you of this data from this time frame that you asked for. Takes a second to load up. But this is cool. And let's actually zoom out a little bit so you can see, you know, a little more of the globe here. So it does, you know, it does take a little bit depending upon the data set that you load. But what you can see here is the data over time, and then you can also save this as a file to your computer so you can use this. So I showed this to some students earlier in Michigan, how they can do that with the SMAP data. And yeah, sorry it's taking so long, but that's the nature of the beast, I guess. Since I'm driving most of this webinar technologically, that's why it's a little slow right now. But you get the idea that what happens here is that, you know, the map, you can create this global map of, let's see if we can do it. Global map of any data set that you like, and you can do a comparison. You can have different data layers on top of each other. So yeah, it's super cool to do. Let's just do a shorter one here. Hopefully that'll load up pretty quickly. If not, you have the idea. Oh, there we go. That's a little better. So that's showing you from January 19th to February 19th. So pretty cool stuff. So yeah, I just wanted to show you that as a possible tool to use. For instance, you can't do it now yet for tree height, but if you're doing, you know, surface temperature or, you know, air temperature, things like that, you know, you'll be able to take a look at that, because as I mentioned in this layer section, you have lots and lots of things to look at. There's a whole aerosol section if you're part of the aerosol campaign. You know, there's precipitation. There's you know, there's land cover. There's everything from methane to, you know, some of the things you might measure, nitrogen dioxide, things like that, ozone. So yeah, so super cool, cool way to look at the data and take it to that next level.
And Brian, I would point out that you can always share these views out using those the tools in the upper right-hand corner there, and so that's kind of a neat way to be able to actually share that link to a blog. The camera right next to it actually allows you to download the data, so it's a pretty neat way to be able to access this information without having to go to a whole nother website. So. Yeah, that right there, you know, can definitely be a challenge getting at that. Yeah.
It's pretty cool. You can pick where exactly you want it to be shown.
Exactly, and the size. So, and one of the things that Brian didn't highlight, but you can always explore too, is the comparison ability down below, to be able to compare this year to maybe last year. And when we're talking about like snow cover, and that gets into a phenology of trees, right? And so that will be something, especially with the land cover being focus in April, that will really allow us to focus on the phenology, the leaf out or the leaf off, depending on where you are in the world. And so we want to try to track that phenology, and that's one of those things that by going out and using the Globe Observer land cover and taking photos of what it looks like today, you'll be able to actually have some reference to be able to compare to these satellite images. And those photos actually can be a piece of data as well that you can compare and actually use to measure the size of leaf or the amount of tree canopy cover that's out there. And so we'll be highlighting that. You know, especially in April, what we can do with those photos, in particular the land cover photos that are coming in through the Globe Observer land cover app.
Yes, awesome. Yeah. You know, the more data, the more precise, more accurate data we have, you know, just helps us build that better, robust data set, you know, for everybody to look at, to understand. Yeah, it's just a perfect thing to use. All right, so Peder, anything else you would like to show?
Yes, I am going to highlight just a couple of final things
Cool.
to maybe give you a little bit more just some different ideas to sort of give some context to those individual trees that we're having you measure. I mentioned, those up photos and sort of the photos that you can capture, and so this right here is really helpful for giving that context of what do you actually have the tallest tree in the area, and what does that look like over time. Importantly, I want to highlight one of the other tools that's out there that can help kind of bring in the history of your location. Because when we're measuring a tree that's maybe 5 meters tall, a question that I automatically have is, well, how old is that tree, right? And so one of the tools that is out there that you might have seen if you've used Google Earth is the time-lapse tool, and so Google has created this globally so that you can go to just look up Google Earth time-lapse. And it's in, I'll share this into the chat as well. And you can go to almost any location around and be able to see the history of that location using Landsat images. And so this can be a really interesting way to give that context to what you are actually seeing, or to be able to look at some of the data in the Globe database and be able to then go and actually travel and see how an area has changed. And so we can actually see, like right here, squares showing up in the middle of our screen, right? And so I encourage you to go explore this, because you can see all kinds of interesting forest patterns that pop up. Here we have clear-cut logging that is happening. That's actually taking these green pixels and turning them into bright brown, for instance. So that's one of those great tools that's out there that I encourage you to go and explore and see what has happened around that tree that you've been looking at. And finally, one of the other tools that I encourage you to explore in terms of giving some context to, and that historical context to your trees, is this site put together by a group of researchers and nonprofits called Global Forest Watch. And this website actually allows you to look at tree cover loss, tree cover gain, where is it happening, not only locally, but also then be able to look around the world and to give that global perspective. And you can also go in here and you can actually sign up for alerts to be told when a fire, for instance, is spotted by a orbiting satellite. You can then be alerted that there's actually something happening there and be able to bring up some of those satellite imagery that Brian was showing earlier and bring in that real world happening now context to some of the questions and some of the things that you're exploring. So I wanted to highlight those two tools as a way of starting to bring in this history component to not only looking at where trees are located today, but where they have been located in the past. And that all helps us to then think about the question of where are trees going to be in the future, and how are we going to monitor those locations.